topic is performance analysis of holography and mixed reality system for industrial process tomography supervision. First of all, I would like to introduce to Tomoverse platform, which is the name of this system. Next, I will describe the tomography and mixed reality, how it's connected, how it works with each other. Then I will go to methods and key concepts of this system of communication, of virtualization and holography. Then I would like to present the results of assessment, performance assessment of the system. It's divided to four parts. So we checked how much time it takes to show the one hologram, single hologram in the scene. We check also the performance of the whole scene visualization for virtual scene, and as well as the real world model visualization. Next, I would like to show how much time the scene initialization for industrial process takes, and the last one, what's the performance of 3D asset update in this system. So, what is the Tomoverse platform? It's a combination of two words, tomographic and metaverse. So it's quite a new approach. It might be seen as the most innovative tomographic platform, I believe, in the world. It has a big opportunity to stand as this kind of system. It allows to create dynamic scenes, manage the virtual assets, create the industrial process scenarios. This system allows also to connect multiple devices types, for example, the sensors, actuators, simulators, and other modules to this system. And what else? There's a tomographic part, so it allows to proceed with forward problem, inverse problem, the simulation for tomographic issues, and execute simple or advanced industrial process scenarios. So let's dive into the system, how it works. We have the Docker platform. It consists of multiple modules. So the composition is very hard modularization of the system. On the right side, I presented the modules that are running when the process is executed. So in the system, we have the message broker. Well, it's the heart of the system. The broker manager that manage the connections to this platform. Between hosts. It's a simple web service that allows operator to manage the data. So adding the new scene, adding assets, modify the assets in a virtual scene. And then very important managers that are prepared in this platform is a scene manager, scenario manager, avatar manager, and of course the main parts of the system is the simulator of tomograph and the tomograph rings. For example, electrical impedance tomography ring and ultrasound tomography ring as well. So when I put on the HMD device, the HoloLens, on my head, I can see the view like this on the left side. So it's the real room with the monitors, computers, some furniture, and what I can see next to this is the holograms. So some cube That's simple geometry, but more advanced things like the containers. Here is the reactor for the crystallization process. It was also presented yesterday on the some presentation. So it's the model of this reactor with tomographic ring, measurement ring with transmitter, because it's ultrasound tomography sensor here, and the plug for this ring that should be connected to the tomograph model. On the right side, there's a tomograph model, some box with the LEDs and some inputs, and the screen. Screen is seen here on the bottom image. So what the system allows to prepare the virtual scene and the mixed reality scene as well. Take a look on the left image. I presented here the production line. Is a table. The line is working, and we can put any phantom, anything on this line, and goes around. And there's a tomographic jaws here that make a measurement, tomographic measurement, and prepare the reconstruction and visualization in the mixed reality scene. On the right side, we have the other process. It's a part of the process of crystallization, but there is no reactors here. I removed to show what is inside. For example, we put inside the two phantoms with geometry of one of the square and the circle inside, and we may click the measurement. So the simulation is done, and the results are presented on this virtual screen. I can zoom this, show that results are here, and we can see two parts of this image that shows that there's some two phantoms. So the system works. System allows to show this and process and show the simulation results. And tomography, so industrial process tomography and mixed reality. What is it, and what can we achieve with this? In literature, there is written that mixed reality and augmented reality and tomography increase the data understanding of the operators. Also, it reduces the error rates when executing the industrial process. Of course, it also reduces the execution time of the industrial process. So we have a lot of advantages of this system. It has a great potential. When we open the user interface, we can select plenty of functionalities. We can manage the devices, virtual worlds, do a configuration, logs, and so on. Visualization is prepared in a Unity engine. The Unity engine is the engine to prepare to prepare games, for example, and it allowed us to prepare the solution for this visualization on the HoloLens glasses. And as we can see on the right side, it's an example scene when we get two panels with presented data. For example, of data of a connected device. Is the production line. We can show the producer model of this device. We can start and stop. So in runtime, it's possible to manage the devices. And on the right side, there's information, for example, about the temperature of the engine, the central unit temperature, the pressure of the feeder on the production line, for example, and the pressure of the tomographic jaws. So what's the concept of realization, and then how the test set was prepared? I can define plenty of data flow models, but the most important are these four. So the CRUD operation for assets: create, read, update, asset operation, and how the data is processed in the system. For example, we add the tomograph to the system. We use the web application. It sends data to Scene Manager. And if it's initialized, it's added to the system. Data is processed and forward to Scene instance. For example, on HoloLens, or also web application, because there's a Scene Manager implemented, so data may be sent also to web application. So the shortcut here is web application sent to Scene Manager and return data to web application to visualize this. For example, the next one, asset update. When we want to proceed with affinic transformation, translation, rotation, scaling, it use this data flow. So from dynamic Scene instance, for example, HoloLens, when we have an interaction with virtual objects, system triggers events with this affinic transformation, this asset updates. The data goes from the HoloLens through the broker to the Scene Manager. Scene Manager saves data to database and, of course, notifies all instances of selected scene to update the visualization. The third path is for scene events. For example, when we click the button, move the slider, or other, for example, UI actions. As well, for the other actions, for example, if some virtual objects go inside to other, and there's a collision actions, and so on. So the same, the dynamic Scene instance trigger the action, sends to the Scalados manager, is the manager that serves the functionality for such entities in our system, which combine the virtual representation geometry of an object and its behavior. So data pass to the HOLOGRAPHY manager and through the broker also to this HOLOGRAPHY instance. It's independent module in the system. For example, tomograph, it might be this HOLOGRAPHY entity. The last one is label update. So if we have IoT devices connected to our platform and generates data, for example, measurements, if it's a sensor, it goes to our platform, and through the broker, it's distributed to all instances in the scene that this device is connected to. So we can also proceed with dynamic updates in real time, data from the sensors. Okay, let's go to the main part of this presentation. So the performance assessment of the system. I prepare five models to test the efficiency of holograms loading. So it's a floor, canister, production line, some phone model, and the car. Car is most advanced model with 230,000 vertex. But what the time of single hologram load to the scene? If you're talking about the floor, it's a simple model. It's a half second. For example, if we're talking about the server mode. Then the canister is about 1 second. More than 1 second is production line. Then the phone is almost 2 seconds to load to the scene, and the SCAR is 6 seconds when we use the server mode. If we use the local host, for example, from this machine only, the times are shorter, and it's presented here. The longest time is for, of course, also for the car, it's 1 second. So we want to present the advanced model. It takes more or less about 1 second. Is the visualization of this data, so the graph. As I said, the car is the biggest one, and it takes the lot of time to load. The production line, so the production scenario entity here, production line is quite slow, so the system is efficient for the production process. When we're talking about the mixed reality, mixed reality allows to scan the real space and model it. So the device use the photogrammetry to measure environment and prepare the model of this real environment, and we can acquire this model and visualize in the HoloLens. As we can see on the right image, it's part of my room, but I don't want to show my room. It's a wooden shelf here, but it's covered by the model. It's covered by the model, the curtain on the right side, the corner of the room here, and some virtual model is a production line as well is visualized here on the right side. If we turn on the collision of the room model, it's obvious that this production line can be set here because of the collision here. We measure the time for loading this real scene to the virtual world, and it takes more or less about 8 seconds to load whole scene. Then the second test, it's performance analysis, and we test how much time it takes to load the whole scene. For example, 98 entities, as the chart here presented. It takes 1.5 second on the local host. The second case is with 40 second scenario, and how long it takes to load. Also more about 1.5 second for the local host, but for the server mode, it's almost 15 seconds. It's very high. The last measurement I want to present is the performance of asset update. So this affinic transformation, how long it takes, and we measure that message count. For example, 100 updates, it takes more about 1 second, and if we talking about 400 updates, it takes 2 seconds. So which if the performance between 100 and 200 messages per second, it's quite a lot of, but not sufficient for our purposes. So we decided to introduce some optimization like caching, use of binary messages to update the scene, and some compression algorithm. And that I said, it's here. So most of these optimization methods were introduced to the system, but not yet verified and assessed. So is the part of the next presentation. I believe it will be the optimization. We introduce the high performance increase. Okay, so thank you for your attention, and I prepare also the presentation, live presentation. If somebody is interested, I invite maybe in the coffee break to show how it works in live. Thank you very much.